Okay, guys, so today we're doing lesson 4-2, which is about step functions. So we're going to be graphing and writing step functions today. So make sure you have the 4-2 note sheet. We are not doing this lesson from the book. Something to write with, and I'm not sure if you actually need your calculator today, but here we go. So this is an example of a step function. Sometimes they call them a staircase function. But this is a piecewise function that's containing all, we're going to say horizontal, okay, or straight pieces. Okay, so if we look at the picture of a stepwise function right underneath it, it's all straight horizontal lines, okay, lines that go left to right. And so it kind of mimics this like stair step kind of look, right? So that's why it's called a step function, because it's all very straight, okay? And how we draw a step function to get all horizontal lines, that means we just have constants like y equals -3, y equals 0, y equals 3. So these are all just constants. You notice there's no x in any of them. But we do still have our x's when it comes to our domain restriction. Okay, remember our fence, our fences. So if we look at it, it's -3 for any x value less than -2. So here's that fence that we were drawing in on the last video. So if you notice, there's that line to the left of it and something to the right of it. So in between -2 and 1, there's our other fence. Okay, we have this expression at 0. So our straight line at 0. And then anytime we have an x value greater than 1, so the greater than 1 would be to the right of that fence, then we would switch to that expression. So we still have our fences showing at where each piece starts and ends. Okay, so we're still going to use those. So the step function there just kind of tells you kind of where to start and stop. So we're going to graph this one here, graph the step function. So we have -3, 1, and 7. So I'm first going to start by marking my fences, okay, because that'll help me know like when -3 stops and we start graphing 1. So we have -5, that's one fence. So I'm going to draw a vertical line at -5. We also have a fence at 2. So at 1, 2, there's that vertical line. Okay, so then within that, we have our 3 parts of our step function, our 3 steps. So when x is less than -5, we'd have -3. When we're in between -5 and 2, we have the value at 1. And anytime we have an x value greater than 2, we have the value 7. Okay, so we're going to have 3 straight lines here at those values. Okay, so -3 means that this line would go here at -3. Okay, but on our fence, we have to put a circle. So look at what inequality we have. We have less than or equal to. Since it's equal to, on my fence, I'm going to put that closed circle. And that graph's going to the left forever. So it's any x value less than -5. Okay, in the middle at 1, so here's 1. We have a straight line. So now let's just put in our circles. So on -5, we have just strictly greater than. So I'm going to put an open circle here. And then we have less than or equal to 2. So on the 2 fence, I'm going to put a closed circle. And then we just have our last line at 7. So this line would go here. Any x value greater than 2, or sorry, 7 for x values greater than 2. So it's going to go to the right forever. And since we have just a strictly greater than, I'm going to use open circles. Okay, so you should never have an overlapping closed circle over a closed circle, because then it's not a function. It's going to fail that vertical line test. So just make sure on your fence, you should have an open circle and a closed circle. Closed circle, open circle. Okay. So now let's apply to some real life problems. So here's an example that we have with Alex. Alex is ordering a gift for her sister online. The table shows shipping rates. So what we're going to do is write a step function and then graph it here. So we have these intervals, okay, and then the cost at those intervals. So if I have to write a step function, so we're going to write a step function. So I'm going to set it up this way. Okay. So what they're saying is our shipping rate is this flat fee for any order between $0 and $15. So this is the cost we're going to have. So $3.99. And the interval is going to come from the restrictions that we have. So if X, our total, is more than 0 or less than or equal to 15, then we're going to pay $3.99. And then this is just going to kind of continue. So I'm just going to write down all my prices. And then the different intervals are where those prices are going to kind of come at. So when X is, let's say, more than 15, but less than or equal to 30, we're going to pay $5.99. When X is greater than 30, now you see I'm not using like 30.01 because I'm just going to say it's strictly greater than, not equal to. And that should cover anything with 30 or more, okay, right? Or less than or equal to 50. And then I'm going to kind of just continue this. So X is greater than 50, but less than or equal to 75. X is greater than 75, but less than or equal to 100. And lastly, anytime we have a value greater than 100. Okay, so now if we had to graph this step function, we'd have to figure out the X and Y axis, which one goes where. So again, we're kind of thinking that how much we order, okay, how much we spend, that depends by giving us our shipping cost. So our ordered pair is X, the shipping is Y. So we'll just say the order amount that we spend, and then that's going to tell us our shipping costs. Okay, so we just got to kind of think of an interval here that it will work for us when we're kind of labeling our graph here. So let's look at our orders. So the smallest value I have is 0, but the most I've spent is 100 or more. So we need to think of like a good interval, something easy. So I think I'm just going to go up by tens. Okay. And then our shipping, the least amount I'm going to spend is $3.99. The most I'm going to spend is $9.99. So we're kind of going from $4 to $10. So maybe I'll just do this by ones. And that should cover all of my stuff. Okay. So now we just have to graph our straight lines. So from 0 to 15, we were going to pay $3.99. So I'm going to say $3.99 is really close to 4. And I'm going to go to about 15, which would be between 10 and 20. Now it's equal to 15, so I'm going to put a closed circle there. Okay, anything greater than 15 but less than or equal to 30, we would spend $5.99. So $5.99, so greater than 15, open circle, but less than or equal to 30, so there's that step. $6.99 is between 30 and 50, so $6.99, so we'll do open circle, more than 30 to 50, equal to 50, so close circle. Next step is $7.99, and that's between 50 and 75. Let's see, 75 would be somewhere between 70 and 80, halfway. So there's that step. $8.99 between 75 and 100. So almost close to 9 to 100. And then anything over $100 is going to be $9.99, so almost $10. So anything over 100, so 100 and to the right forever. Okay, so that's how we would graph that step function. Now, if we're talking about the next problem, asks us to write the domain, okay, using inequality notation and interval notation. So remember, the domain is all of our x values. So what were the x values we had? The smallest we had was 0. Okay. And our x went from greater than 100. So 100 and on forever in the right direction. So we could say from 0 to infinity. Okay, so we spend $100 or more, doesn't matter. Our shipping is $9.99. Okay, remember inequality just says we can write it using an inequality. So x could be greater than or equal to 0. And again, we're talking about how much we spend on our order. So we don't want any negatives. We can spend anything greater than or equal to 0 online for her present. Okay. Let's do one more on the next page. It's not as long. We have a wholesale t-shirt manufacturer charges the following prices for t-shirt orders. So he's going to charge $20 for any orders up to 20 shirts. Okay, $15 for shirts that are from 21 to 40 shirts. $10 for 41 to 80 shirts, and $5 per shirt if they have over 80. So we're going to write our piecewise function. So call it whatever you want. F of x is just normally what I use. And so our values are going to come from what we're actually going to pay here. So we're either going to pay $20, $15, $10, or $5. And then we'll use these values here to give us our intervals, right? So we would say when X is for shirt orders up to 20 shirts. So what that says is we would order either 0 shirts or up to 20. So more than 0, but less than or equal to 20. Okay. I'm going to kind of erase this because it's in my way now. So we're going to pay $15 if we have 21 to 40 shirts. So I would say I'm just going to keep the numbers for greater than 20, not including 20 because we already equal to here, but less than or equal to 40. Okay. Now the reason I'm just kind of putting 20 to 20 and not using 21 is because I can't really have a half a shirt. So this just means X is greater than 20, which implies greater than 20 would be 21 shirts. Okay. We're going to spend $10 if we have more than 40 shirts or less than or equal to 80 shirts. And we're going to pay $5 if we spend more than $80. Okay, so your numbers are always kind of going to match up here. You just want to make sure one of them is going to have the equal to and one of them will not. Okay, because remember, we want to keep that function notation. So graphing this, we need to set up we have to kind of graph our intervals here, kind of what we want to label our axis. So we have how many we order. So we'll just put number of t-shirts. That's going to be our cause. Our effect then is how much we spend, right? So X, Y. So let's see, my smallest X value is 0, but my biggest is 80. So I think I'm just going to use tens again. Seem to be the easiest. Make sure you use something that's easy for you to count by, okay? Something that you can do quick. I'm just going to stop there because all I really need is to 80. Okay, and like our smallest amount we would pay is $5. The most is 20. So maybe I'll go by, I know this has 10 lines. So maybe I'm going to go by 2s. 2, 4, 6, 8, 10. Okay. All right, now that I have that set up, we can go ahead and graph everything. So we're going to spend $20 if we're between 0 and 20 shirts. So I'm leaving an open circle on 0 because I'm not really going to pay anything if I don't buy anything. So I'm not going to use an equal to there, but so from 0 to 20, including 20, we would spend $20. Okay. Price drops to $15 when we go from 20 to 40. So 15 would be about here. So 15 to 20 to 40 is $15. It's $10 if we go from 40 to 80 shirts. And then it's $5 if we have 80 or more. So $5 if we have more than 80. So there's all of our steps. Okay, so a little follow-up question here. How much would you pay per shirt if you ordered 27? Well, what interval does that kind of fit in? If we ordered 27 shirts, how much would we pay? Well, 27 kind of fits in that interval, right, from between 20 and 40. So that means I'm spending $15 per shirt. So our domain, if we look at the x values, we started at 0, but we can go anything bigger than 80. So if we start at 0, this graph is going to keep going no matter how much. So any value bigger than 80 is going to cost $5. So whether we order 80 shirts or 80 million shirts, they're $5. So I would just say 0 to infinity. Or we could say x has to be greater than or equal to 0 because we cannot buy a negative amount of shirts. Okay, the range here is a little different because we don't really have an interval. We only have these set values for our y, our cost per shirts. So for a step function, the range, okay, is just always the values that you have. So y could equal 20, y could equal 15, y could equal 10, or y could equal 5. We only have 4 values that are available for the range, or our y values. So you would just kind of list your numbers from your step function there. Okay. So again, you set up your values, what you're kind of getting from the function, and then read the problem to kind of get those intervals. Set up a scale for your axes so you can go ahead and graph it. So you guys are going to try this last one. That says a parking garage in downtown Chicago costs $10 if you park for 5 hours or less. If you park there for more than 5 hours but no more than 10 hours, you're charged $25. And if you park for more than 10 hours, the fee is $60. So start first by writing what's that piecewise function. How would you write that? So I'm calling it f of x. So draw your kind of your big bracket and then put in your values and your intervals there and see what you get. Okay, here's what I got. So $10 if we park for 5 hours or less, so less than or equal to 5. $25 if we're more than 5 hours, but no more than, meaning less than or equal to 10. And then $60 if we're there for more than 10. Okay. So next what you're going to do is go ahead and set up a nice scale on your axes for yourselves and graph that piecewise function. So take a second here and pause and graph that for yourselves. Okay, here's what my graph looked like, and yours might look a little different if you did a different scale than me on your axes. So I went by 2s along my x-axis since we're going from 0 to 10. And then up my y-axis, I just went by 10s because I have from $10 to $60. And those are my steps there. So here's a question. If you parked there for 8.5 hours, how much would you have to pay? Well, hopefully you said you'd have to pay $25. 8.5 hours would fall in this step right here. So that would be between 5 and 10 hours. So you're paying 25. So next, how would you write the domain here using inequality and interval notation? Okay, so you could say that x has to be greater than 0. Okay. Or you can use the interval notation where you'd say from 0 to infinity. So you can park there no hours, or you can park there infinite amount of hours. So then how would you write the range? So remember, the range comes from your 3 steps. So where are those steps at? It would be y equals what, and what. So hopefully you had y equals 10 for $10, 25, or y can equal 60. You only have 3 values for your range because you just have 3 steps. Okay, so those are a special type of piecewise function called a step function because of the picture it kind of makes. Looks kind of like a stair step or a stairwell. Okay, so those will always be straight horizontal lines. So you'll never have a variable with your numbers there. All right, so we'll see you in the next video where we do a little bit more graphing.